Alright, so that was my short break. DieCaveS, I'm going to go. Yes, I will be doing the competition. I don't know if I'll start tomorrow because I have to do something tomorrow evening. I'm off playing games somewhere. And that's when the competition starts. And so either I would start really late tomorrow or possibly just start Saturday morning instead and have a really early morning. And then if you can't join me in the morning, then you'd have to pick up in the evening. And I may come on and off. And tomorrow I might just do a Leaf stream for the day. And we'll see what happens there. Alright, so now it's back to this. This score special. I think it's a bad idea. Let's back at a score special. And let's start looking in the future. Oh, I have an error now. Yeah, we'll get rid of that score special. I guess we have, it's 10 days long, isn't it, the competition? So if you can't put time, yeah, 20 hours counting down, so we have like, yeah, 10 days I think it was. I think they made it so it covers 2 weekends. That gives us plenty of time. Other than the streams, I don't have much time to put in anyway, so whatever I do tomorrow evening and Saturday, I want to see how far I can get. There's 3,000 people. I'm really trying to get some points at it to get us into Masters, so anywhere in there should be good. And we'll see what happens, but the current rate we're doing, I don't get my chances very hopeful, but what I'm learning so far from this is that scoring, all this stuff here, let's get rid of this. All this special casing is bad. It works. The scoring has to be super simple. You know, we have to be looking in the future instead. Now, looking in the future gets very costly, but we just have to try it. We'll see if we can do it. And I wanted to save this thing. Git commit. Blech. Percentile, I don't know. What percentile am I aiming at for this competition? I'm hoping for the top 99%. I don't know. I really don't know. There's a lot of coders. Code for Life we're doing really bad at, but there's not many people in it. Okay, Renax, you're saying it's actually easier? Well, we've been in gold in all the other ones. Code for Life is the only one we haven't gotten to gold to, and it's just kind of frustrating me. And I think it's because I screwed up the scoring, and I'm trying to rescue a dying beast here, and I should have just given up on it a long time ago. And yeah, I'm guessing the reason they do competitions is to actually get the bosses, and that's where they come from. So I'm guessing the bosses are just hand-picked from somewhere in the competition. They just ask the guy, and here's one. And Code for Life seems to be really hard, and I think it's because there's not that many people in it. The other competitions we did quite well, or maybe it's just the structure of it. Maybe I'm just doing something horribly wrong, and I think I am doing something wrong with the scoring. And I think it has to do with I made the scoring too complex. We have all these if conditions and all this stuff with if and this and that, and that's really screwing up. And yeah, I'm going to try and do the multi-step prediction now. Well, not prediction, I'm just going to do multiple steps and see where it goes. You even asked? And yeah, right, because they don't ask them. Wonderful, okay. I guess, yeah, that's... Not working is certainly a downside, and mine, I feel so frustrated that, I mean, we're going backwards. We had a 64, and so we were up there, and we should have just, I should just revert to the code. What code, what do we do that got a 64? We just go back to that. We were doing well, and I should have just done back to that and done the scoring, but I don't know where we are now. And Coin, I've noticed that. I've noticed a lot of them are starting with rank 2, and we just have to pick them up, and a lot of them get blocked. And that doesn't feel satisfying because it's not a scoring-based one. I'm trying to come up with something I would figure that out on its own because there's a lot of strategies I know we could hard code, and I think that's the approach you took, is just basically hard code a bunch of small strategies, and it apparently gets you very far. And I was jumping straight to sort of that end game, saying, all right, let's just go right to the end. What's the most generic way we can solve this? And it's totally bit us in the ass here because, I mean, it's too complicated. But let's just step in the forward future first, and we might want to look back. These samples, simplify the sample stuff. I don't know. Let's get rid of this. We don't need this. So this sample's worth 0. We can prove the ranks. Which submission do you mean, IKFS? Yeah, you submit. So you submit every time you press submit. It's going to update your score, and if you check your history, well, it doesn't give me a history of the scores, unfortunately. That's kind of silly. I thought it used to give me the code for the scores, and other ones it did. In golf it did. Apparently not here, though. So that kind of sucks. We used to see the history of the scores. All my cleverness is not being rewarded now. I don't know about the competition. I have no idea. I've never done a competition before. My competition experience is 0 on this, so I just don't know what happens there. Man, I'd really like to be able to return this to the state where we're getting 64, but I don't know what that was. What was I doing to get 64? This is the baseline scoring. This stuff here is weird. And that log 2 was weird. I want to see where this gets us. I'd really like to have... Man, I'd really like to get back to that mid position before I do the turn-based thing, because I think that was a good algorithm, but then we tried messing with it. I mean, it really wasn't that good, but... At least it was better than position 190, but maybe it got more... maybe the competition got better. This is the thing I fear. Every 2 days they release a new boss in contest. So they create a new league? Recognize, did they create a new league every 2 days then? Alright, let's just start looking ahead here. Alright, so at least we're learning something. Even if we fail here, we learned scoring has to be simple. That's clear. Diagnose more, and so we're going to go to the scoring thing here. Get best turn is very complicated, though. Let's do a dump state. Okay. So as long as we just got to stick ahead of the curve somehow. We're at here. Well, this should be part of the dump state. And I don't think we're doing any better here. Totally mixed. The ranking is just awful. Maybe the competition did just get better since last weekend. There's actually more people subscribed to it, but I highly doubt that. And I don't want to go fill. Let's just look at the future scores. Let's assume we're okay, and we just have to look at the future scores. This is where it gets really complicated and where debugging is basically impossible at this point. So what we want to do is we want to say for each state get the best turn. Let's wrap this up into one though. Get best turn of turns. Function get best turn. Return a turn. We enumerate the turns, and then we're going to say get best turn of ourself. Ah, yeah, this is kind of really shitty here. This is going to cost us so much in the performance. What killed us in Tron was that we just didn't have enough CPU time to process stuff. And turns. Because what's going to kill us, they're going to do this in a loop here. We apply it. Now the self.clone, we know how to fix this here. This is extremely expensive as well. And we don't need to score it every time. What we need to do is do a depth. Depth I32, and let's look 2 down. This is just going to kill us. Get best turn of depth -1. Now let's put the depth down here. Depth I32. Now this is a little bit weird here. We don't have to care about that too much. How am I trying to do this? No, I enumerate all the turns and I apply them. Then take the maximum of all of them. Yeah, no, I have to apply the turns. Just a second. I'm thinking. We want to do get best turn. I need to score the turn. Let's do this. Let's do score turn. And self turn. F64. We need to do a let mut dup equals self.clone. Dup.apply turn. Dup.score. So the best turn of becomes right. I have a hard time setting up this recursion always. It takes me a bit to figure it out, to unwrap it to depth. Basically what I want to do is take all the turns we have and for each one apply all the returns that follow after it and take the maximum of those scores and just go a few depths deep to each of them and pick the one that picks that topmost score that has the maximum score. How can I do that? It's a tree. search down through all the trees, the ones with the best score without actually creating the tree, the maximum of each leaf. And we carry the score back up, score turn, scores a turn back up, and this is where it has to have a depth. When we say if depth equals 0, this is where we return. Yes, it's basically well, it's a breadth first search kind of. Well, it's kind of hard to say. I'm not searching, although yeah, it's more of a breadth first search. I have to completely go through the breadth of it, and so each level of the tree I have to completely go through all the turns because we can't predict what they're worth. But we could start doing trimming based on a few turns, but based on our scoring, we know our scoring is so shitty that we can't actually do the trimming yet. So we do self.score here. Otherwise, we duplicate our cells, apply the no, we have to apply the turn in any case. No. Yeah. Should do it here, yeah. The depth is 0, otherwise we do let turns equal vet new. Enumerate all the turns we have now, so dup.enumerate. And turns. And for I and 0 turns.len. So we're going to do a let best score equals 0. We'll assume we don't have negatives. I don't care about that. Or actually, let's make it really low just in case. Let sc equal self.score turn. And this is dup.score turn. Dup.score turn turns I. Best score equals best score.max sc. Then we return the best score. So if there's no depth left, we've scored this one. Otherwise, we check all the possible turns and return the best score of all of them. And this only evaluates the leaf nodes. That's what I'm trying to do. This will only evaluate the leaf nodes. So when we do get best turn, the first thing we do, get best turn, says enumerate all the turns and get the best turn of. All right, and this is the outermost loop. The outermost loop is the one actually evaluating this score because it's the one we want. It doesn't need to do a clone. It does a score of self.score turn. Turns I. And a depth, we'll start it at this depth. Whatever that is, yeah. Probably depth minus 1. No, we're calling depth minus 1 everywhere. Let's return depth, let's return depth. What do I want? A depth of 0 does... Yeah, logically a depth of 1 is the lowest one because that has to go one level down. So depth of 1 is the minimum less than 1 sanity check. And this would be the algorithm we have before. This is exactly the algorithm we had before if we put 1. And now we put a value of 2, and most likely we're going to get a timeout. IKFS, what you've described there, your game state that owns vec of other game states and then passing vec of functions that mutate, you're pretty much what we do is we have a game state and we have a turn and we apply it and we duplicate it. This self-clone here creates another game state. This self-clone is creating a game state and dup applies applying the turn, and then it's going through the list of possible turns and applying more of them and finding them. I don't find the total score, I'm finding the maximum score in the children. That's because of how our scoring works. We shouldn't total them up. We're going to find the maximum at any point. And so basically the same way, but ours doesn't work either, so you know. I can show you what turn looks like. Turn. I don't know how to turn in case sensitive. Come on. Turn type. So turn is this. Turn is a structure which has 3 values. What is a turn type? We have goTo, connect, connect type, and wait. We have a destination module and an ID, because these are the only turns you can make in the game. And so we just encode what possible turns there are there, and we pass them around. The only difference between connect and connect type is because at the molecules you have to emit the letter as opposed to the number. I don't know why they did it. They just did it to mess with us. Destinations only used in goTo, and wait doesn't use any of them in IDs. So encoding the turn is pretty simple, and we do this by copy and clone. So this is a by value structure because this is really small. We don't bother creating these pointers to objects. They're really small. And function and mid games. Oh, so you're applying so each of your potential turns is like a function pointer then, is that correct? IKFS. You have function pointers for turns? I mean, it will work. I think it's a bit harder to inspect though, because ours makes it really easy to debug the turn type. We just dump the structure out and you see exactly what turn you're going to take. It's easier to deal with because function pointers have this problem. They're very hard to deal with data, even though they're considered first level objects or high order object, whatever they are. They're just harder to debug and harder to deal with in general. Though they do allow you to do more things, they allow you to encode more intelligent turns, but we could still do it. I have a bunch of switch statements though. Switch statements aren't so much fun. Okay. What? I have an error now. Okay. Dup score turn. Oh yeah, depth. Now this is the depth -1. Depth -1. We don't even need turns anymore. Okay, now what I'm afraid of here is we did a depth of 2. Because of how we're doing the apply and stuff, I really fear it's going to take too long, because this is a lot of processing we just did. We just ballooned the processing to a ridiculous amount. It might be enough to do depth 2. Depth 3 might be an issue, though. And we just wait. Oh, you can do, yeah, that's not worth it then. Hyperthreads aren't actually threads, and we're not waiting on memory. We're not really waiting on anything. We're doing raw calculations, so there's no wait cycles in this. This is a hyper-threaded core only works if you have. Are you making fun of me now or my robot? Oh, wonderful. Well, he does something. Let's just go back to make get turn 1 to make sure my logic is correct. This should be the old algorithm. Alright, no, see, we have an error. So even at a depth of 1, we're doing that. So I did something critically wrong here. Get best turn. We take the turn, enumerate all turns, we go down to this depth. We provided a depth of 1. So what does that do? It does a get best turn of. Okay. Best score none. So we score the turn. Turns I, depth minus 1. If the score is better, so this loop looks the same still. And score of none, fine. Score turn. If depth is less than 1, no, less than or equal to 1. And that should give us our previous algorithm. Of course, it won't fix the fact we do silly things. Alright, so I've broken something. Because I'm guessing it trips up this one here. Best score is best score, and I told you best turn. Can you print an optional? Hopefully this works. Oh, wait. Best index. Let's just do best index. Alright, so what did I break? Score of 0. None, 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 none. It can't have none. Most of the time it's finding none. Turns out len is 0? Well, let's see what turns it gives. I can't believe the turns.length would be 0. Unless I have a whole bunch of negatives. Alright, just pause this nonsense. What do we have? What do we have happening here? Go to diagnosis, go to wherever, go to sample, should be worth more, but you know what I did? I changed something as well at the top. Score. Wait, no, I didn't change that. I left that in. What did I break? What did I break? Where is always 0? Score where? How is score where 0? So we're at the start position. And where is always 0? Well, this is weird. Something broke that I didn't intend. Or I'm scoring the wrong thing. That's quite possible somehow. Calling a score on the wrong object. Dupe.score. That would make a big difference. I should hope it makes a difference. So this should be what we had slightly before. I simplified it a bit, but at least we're doing stuff again. Alright, so at least we're doing stuff, so now we can at least try to implement that. Let's double check this again. Dup, dup, score turn, dup, score turn, best score max, dup, 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 dup. There should be no self in here except the first self clone. Good, so let's go down to a depth of 2. Now we're going to have to cheat a bit here, but that'll be okay. Because movement takes time, we're actually going to skip over that time and make them jump directly to the next thing and just start evaluating from there. It's hard to tell if we're doing any better. We lost against this guy last time. So that clearly wasn't a good thought. Alright, let's see how far we can push this up before we get a timeout. Let's do the right to 5. I highly doubt we can do it. But 5 would get rid of the ETA stuff. And our prediction thing is totally ignoring what the enemy does. We're just considering ourselves, which may not be good. Now, what is this? Playing with this little yoga thing? Something's going wrong here. Where does that minus come from? Can the turns be 0? Let's see if those turns are ever 0. There are. There's definitely ones where there's no turns to do. How is that even possible? How can we have no turns? Oh, I know why. Wait. Because this generates no turns if there's an ETA. Now let's leave that in. But what I'm thinking of doing is when we apply a movement, they just skip over the movement. So we see what we do at the next thing. So the movement, we just increment some counter, and we just ignore the actual time it takes to do stuff. Well, this is nice. Waiting returns the best score still. Oh, come on. Samples has to return more. Look right here, Samples had a higher score. because it went further down, and these ones... Well, why did this one explore so much and this one not? This one didn't explore anything. We're not getting the exclamation marks now, which is good. But they should have explored something. So like this one here, it explored just one option, which doesn't make any sense. And this one explored several options. Because this one was only waiting. Because it takes so long to get there, they were only waiting. 10? That's going to be too high. But 5 should have got us there. That's just really weird. Oh, I know why. We're probably not applying weight correctly. So that's going to make no difference there. Apply weight. Weight actually has to do something. Self.players.0.eta is greater than 0. We have to reduce the ETA because something actually happened. And that's why they're not searching anything, because the moment they start moving, they have no future options, and so it's not actually evaluating anything. But without offline tests, this is, you can see it's going to be impossible to debug this stuff now. And so we have all sorts of options here. That's wonderful. That's what we want to see. But we still do nothing. Sigh. Okay, so I'm going to do one thing first of all. Is I'm going to put in the state dot. Where's our state? Where is struct state? Remain turns. We're going to make an I32 to this. How many turns does the game have remaining? And somewhere this is loaded. It's in the thing, I can't remember. There's a number here, 400. 400. Their searching sucks. These complex web apps, you can't search through them anymore. Number 400 here has to appear here somewhere. Okay, where does it say that? It doesn't even mention it anymore. It mentions nothing about how many turns are left. Alright, so we'll just hard code this. State.remain turns equals 400. Actually, we're going to put 401. I know, it's fine. Self.remain turns minus equals 1. The reason I'm doing this is so when I apply the weight, I can apply weight differently. I can do this self dot remain turns minus equals self.player 0 to eta minus 1, because we already subtract whenever we read turn, or do we not? Yeah. Self.players eta equals 0. So we're just going to skip over the whole waiting. Waiting just costs nothing. It just jumps to wherever we are. Main turns minus equals 1. So it's applied a turn there. So that'll skip over waiting, and that should give us more options. And I'm going to reduce this down to just 3 here instead now. And our sample thing should get ridiculously long here. We might not be able to see anything anymore. Might just see the timeout it produces at some point. It does nothing again. Waiting can't be a value. So if waiting is a go to turn set 9, 60.9, then there must have been go to samples, must have been 60.9. Oh yeah. Wait's going to have the same score. It has exactly the same score because waiting and doing something has the same value as doing something. So now we can actually take the score and apply the ATI to it. This is going to be really weird. Score. Let remain f64 from self.remain turns. Anything that gives us that keeps higher scores is worth more to us. That may fuck with stuff too, but oh, we'll find out. At least we'll do something. Or not. Do we end up with the exact same score? Alright, so that's not a good idea. Sitting. How do I get rid of the wait? How do I get it not to consider wait? Because it's supposed to be bad, because going to samples gives it that 445.9, and just going directly to samples gives it 4440.9, which is weird. Should be worth more because here it gets there quicker. When it gets to the samples, it should have a higher score there. Why does it not have a higher score? So if you understand what I'm saying is that I put the remain score, I'm adding the remaining turns in. Because every turn we have left, and that's supposed to be wait. What's supposed to, is wait saying, okay, I'm going to wait, and it said, well, when I go to samples, then I get this value here. But that seems wrong. But this is one lower. I know why. I think. Let's look for weight. What do we do when we apply the weight? The ETA is greater than 0, okay, so that should be fine. We have something wrong with the scoring here with the remain turns minus equals 1. If we apply a turn, we return a turn is gone. And if we're waiting, if there's an ETA, we just go there directly. We could probably do the same with goTo. Let's do the same with goTo. Minus equals ETA minus 1, I think, or yeah, I don't know. Does that have minus 1 there? We'll have to take this turn. That's fine. We've taken this turn. I don't think that's correct. In waiting, we've applied that turn already. But that should have worked. I don't know why that didn't work. I think waits connect going too fast down. Look, he's doing something now. Sort of. He picked up one sample and stopped. Why is waiting worth so much? It's coming back to us, so it's not helping anything. So Regnactus, your comment is really, correct. Because every time we do something, our score goes down. Except to connect to diagnosis. And we have an equal score here. How do I break that equal score? Yeah, this pisses me off. This is back to our exact scoring thing. We had the exact same problem with scoring. It's not helping because we have weight now getting a higher value or being exactly the same. Because it does something at diagnosis, probably. Oh wait, so weight should cost a turn. As would connect. All these things cost a turn. goTo costs a bunch of turns. And if I do look further, does it fix whatever weird problem I have? Now it fixes it by having a timeout, so we can't go down to 5. It's a problem. We know how to speed this up, but what do I have? Okay, now that I have this though, there's one thing I can fix. Because I don't wait for stuff, I can get rid of this where value here. Just get rid of this. We don't have to consider potential value of going somewhere. The value of going somewhere is nothing now. Because we have the remain, we just don't need it at all. So we consider doing something at one place or going to the other place and doing something and we still get stuck waiting there. Come on, come on, come on, come on. What are you doing? We still have this 588 here, is matching exactly the waiting score. How can that possibly be the case? We diagnose a bunch of stuff. Waiting can't be worth more. 2. All right, let's just do something. I know why it's like that, because we don't do enough to improve the value. If you diagnose the sample and then wait or something, then there's just not enough to improve the value over 2 turns. So we just hard code it. Let's do it this way. Best index is none, or score is greater than best score, or score equals best score. Actually, no, this is simple. Patience factor. Well, then he's still going to end up waiting 1. And that makes a lot of sense. But the problem is he's waiting at places he should not wait at all right now. So I'm just going to do something silly. Score turn. If turns I dot type equals turn type. Wait. Just stopped at the balance, but I'm going to have to go back to the patience thing as well. That makes a lot of sense. Because he's supposed to wait sometimes. Oh, come on. This is one of the nuances in Rust. I mean, how can you do a match on a turn type but not be doing equality? That's just silly. I need to break this loop. So turn is awaiting automatically gets a -1, which is really bad, but at least breaks our loop because I have some logic error. It shouldn't happen if we can go far enough in the future, but our ability to go in the future is going to be greatly limited. What? Now what's it doing? I made it worse somehow. Well, interesting, the best is 419 when there's a 428 right here. Oops, because I messed this up. Alright, that's what it did. We're doing some weird stuff now. But we're picking up high-valued things right away. Which is really weird. Like, he's doing really, actually quite well. Almost. Doing some bad stuff. So we actually won that time. We lost before. It's doing some weird stuff, but this is actually shows promise. He definitely did some stuff that looked halfway intelligent, you know, combined with the stuff that looks stupid, but he did halfway intelligent stuff. So let's see what happens with that. If this holds promise, it means we can increase the depth. And increasing the depth just means optimizing it, because our depth search is really, really slow, and it's because we're cloning, and why is he picking up so many molecules, though? That's really weird. And he's only ever picking up one sample, which is bad. Though picking up one sample is a scary bit. I guess yes and no. It matters because we have a fixed amount of time we can do stuff. If that time runs out, it just assumes we wait and we crash. So that wasn't good. We're not picking up enough samples now. Well, kids, if you have an encounter that, just increase your depth count. Just keep increasing your depth count till you run out of time. Hey, look, we both got stuck there. Oh, and he had a weighted patience count. Huh. Yeah, 3's not very far. We're doing 3 right now. We have a couple issues. I'm trying to figure out why we pick up so many molecules, even if we don't need them. Well, we might be picking up molecules for samples we don't have. Shit. Can I go to 4? Oh, I'm running out of patience for today, and I'm not going to be able to come back to this for a long time then. Oh, we can't go to 4. 3, we already hit a limit until we optimize. Now the question is, why would we be picking up not enough samples? I have a good idea of why. So the reason why we might not pick up much samples is because an analyzed sample is worth more than an undiagnosed one. So what happens is, if you're doing multiple moves in the future and 3 is just enough, if you have a sample, you can either pick up a new sample or walk and diagnose it, and that's automatically worth more. So that means just having a sample has to be worth more than walking over and diagnosing it. Now, how do we do that? How do we make that work? Wow, so this just opens up the same can of worms, but changes all the scoring values. Hello, Lazik. What up? Yeah, we've created an AI that walks with my everything. You're rewriting everything. Rewriting the scoring because now it walks in the future, and we have to rebalance the scoring. So that we have the problem that when he walks into the future, there's not enough value to pick up multiple things at one place. So that kind of sucks. Not a problem. We're not valuing the ETA enough. The ETA loss is... How can I do that? Future score is not... Ah, crap, man. What I could do is I could do something really stupid. And see if it helps. We'll just divide this by 400 because we know that's the maximum score. And we're just going to times the whole thing times remain. So that values early in the game are worth more than those later in the game. But that might not make enough of a difference to overwhelm it. So we prefer score early over scored later. Just weird. Now we still pick up 1. Silly robot. Let's take off the division. Still pick up 1. Okay, now the reason I only pick up 1, and actually I understand this now, is because if we could analyze more, it's really weird you picked up the red one, because I can't fulfill it. Simplify more is that we have to look more in the future. 3 is not far enough. Because the reason he picks up 1 and goes is because it's worth a lot. But if he analyzed further, he would analyze that picking up 2 and going over and analyzing would be worth even more. But we can't get that far in the future. Unless we can speed it up, unless we can get down to 4. Anybody know how to profile Rust? How we can get timings? This is going to be almost impossible without an offline thing. There's going to have to just be guessing at the timing here. Yeah, and that's 4 is too long. Okay, so IKFS, we have the problem, though, that if I have no way to run it locally, I can only run it online. Because I have no framework which to run it, which is a fundamental limitation here. Oh, man. I'm thinking of giving up. Let me explain what we have to do to speed this up, then. Assuming we had a benchmark, is right here... we'd modify this, and this dupe apply here. Yeah, I mean, the issue I care is we don't really know. We need to sum up scores. I need to know, like, per function breakdown. I need, like, a function breakdown, because we're doing recursion. So the instant, it's always measuring the same thing. We need to break it down per function, which makes it really hard to do stuff like instant. If I had expensive functions, which I don't think I have any actual expensive functions other than the clone. I'm guessing clone. I don't think it's apply. I'm guessing clone is the most expensive part. And we need to average these up and do all sorts of weird stuff. I have to provide initial states, but you have a good point that it might be, yeah, but we'll get stuck in the initial states. We don't know for sure, but that would actually probably help a lot. That might work. Destroy computers, yeah, we can do that. We can definitely get some input. We can get the input to the first turn. And if we just profile on the first turn, let's do that. Let's learn some Rust. Before I give up on this, let's actually learn some Rust. Let me explain what the other option is first, is that I assume this cloning here, I'm assuming this cloning is really expensive. It may not be the case. We're going to find out. If cloning is expensive, what I'm going to do is I'm going to make apply, return an undo state. And so we can undo it instead, and then we can avoid the cloning. And avoiding the cloning, I'm hoping, would speed it up. But let's actually get the input running first and get the initial input. We have it somewhere. I think we can actually see the initial input, can't we? No. So all we want is the initial input. And we're going to do that by doing a load standard in, load print line, input line, it's kind of yucky. Don't show those for a second. Input line, input line, input line. Read player is going to have to output that. And return. 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 I should have made a function to read this line and emit the output. All right. I like putting spaces between things. So the spaces in this editor are too big in a proportional font, so they screw that up too, but that's okay. All right, let's see what we get for output. Alright, is this the initial game? Alright, so we have a test file. How do you create a new file in this program? There we go. What did I change there? And it disturbingly didn't put the extra lines we saw there, but I'm okay with that. There's a science approach, that's fine. Input 1.txt. How does it work, I guess? Let's search for this. Rust. I want to see an example. Rust. This never works in search engines. I want a programmer-friendly search engine. Useless. Rust cargo bench. Let's look at the one in the Russ book instead, even though it's outdated. Alright, is there something better in the second book? I'm afraid this stuff never works on me. Let's create a second file. There must be some way to get this working in a second file. Thank you. That looks easier than what they had. Now, can you answer a question? How can I import my other thing in the benchmark, or can I just stick this in the same file? Let's just stick it in the same file for now. Let's forget about the crates. So if I call cargo bench, will it call this stuff? Oh, that has to do some stuff, of course. Unresolved import test. Yeah, okay. How do I install it? Can I import it from main? Mod main? Let's do that. Let's stick it in a different file. Can I do mod main? bench.rs. Will this do anything? Did that second file make sense? How do I add the second file to my thing? Where's my TOML file? I can't do it the other way? The reason I want to do it the other way is because main is what I have to submit to the program. And I'm going to have to keep commenting it out otherwise. Unresolved import. So where's test from? IKFS, do you know how to get the test bencher? I have to install a crate somewhere. Alright, where's that thing I just opened? Test equals star, I guess. Cargo build. Test. How do I install bencher? Like that. No. No. What else do we have for soaping? What about this thing? Is that still necessary? Oh, I did indeed. I do that a lot. There was the trucking situation, the great dispatch problem where we had crates, and I kept writing create every single time. No package name tests. Take this out, I guess, maybe. Use of unstable library feature. Okay, that's fine. How do I do, how do I use an unstable library feature? Put 0. I've got that right at the top. I've got it right up there. Needs to be in main, okay. It still says unstable. And it also says wonderful modularity. So this probably has to go up here first as well. It just doesn't like it. This has to go right at the start. May not be used. Ah, come on! I hate this about Rust. Just let me use this thing. So we have to do something else. May not be used in the stable release channel. Plus nightly plus bench. All right. It ran something. Wonderful. Okay. How do I load a file in Rust? Well, this is a problem. I need to pass something into it. So I need to do something like, what does iter do? I don't care about it. I don't. Alright. Yeah, no, I got that part. But I need to load something from standard in. The problem is I have this load standard in, and I have to pipe something to it somehow. Oh, so you did do something. Okay. So I really need to pass. Mod main. Use. So can I do this? I'm not quite sure. I'm not quite following where I had to put this stuff. use state. That's what it was. Okay. Now it's failing, so now I have the second thing. How can I put something to standard in here? Or, more importantly, how can I pass standard into it? Is there a standard in stream? What is standard in? There must be another stream somewhere. How do I create a stream out of a file or pass the standard inputs? Oops. Rust standard in. What does this implement? Implement standard in. Well, that's not helpful. Implement read. So I want something that implements read. So let's check out if I can do this first. Let's fix main first of all. So if I go to read standard in, load is going to be a from, and this has to be a read from.readLine. Hope this is correct. Yeah, I don't care. Cannot find type read. Where is using standard IO read? No, I need to have it so I can parse it line by line because I don't want to change my parsing thing. So I need to have a read structure. But that looks like it's correct. Load, read. Read players from read from where is standard IO? Standard in. Return is from read. From read line. It's in the same place. Return is from as well. Load. Return. All right. Probably. Well, this breaks my CLI. Whatever, I just do this way. Are you sure I want to have and there? 832. Let's do clear and get this right. Read line. Oh, come on! Read doesn't have read line? Why would they do that? Why would you put an extra function on standard in that's not on read? BufRead. Alright, let's do BufRead then. Alright, let's do that. Do BufRead. And read becomes and BufRead. BufRead? BufRead. Sounds like my butler, BufRead. But standard in is not a BufRead. Wonderful. Alright, see you next time, guys. A lock standard input does. Alright, well, let's do that. Let from equals io.standardin dot lock. And from. And from. I didn't press save. I did. Where's that? That's what I want there. Okay, so I have a load. Now, how do I load a file? BufRead for input1.txt. This is what I need now. BufRead. How do I do that? Rust. BufRead for file. BufReader. That looks good. Don't know what that question is, but hey, let's work with it. Let f equals file open. We're learning something new today, even if we're not famous. Anyone know what this question mark here is? Let's call it from like we did before. And what is the try macro? I don't know what the try macro is either. Is that like that? I saw some try macro stuff before. It was like some really ugly exception handling stuff. Okay. I think I got that. I guess I have to. Use, what do I want to use? I want to use standard IO BufReader, use standard IO file. Standard FS file, that's fine. Where's my error? Temporary value does not live long enough. Well, that kind of sucks. How do I lock it? Can I just take a reference to it? So this has to be a mut BufRead. So let's find all of them. BufRead. A mut BufRead. Mut BufRead. Mut buff. That is a weird name. Mut BufRead. And so these at the very end are going to have to be a mut from. Or mut from. And these have to be mut froms as well. Mut froms and mut froms. Oh, I screwed that one up, yeah. I was looking for that. I knew I screwed that up. What else did I screw up? No method named return. Alright guys, that's that one. It's fine. Cannot borrow from mutably. Why not? Oh, that's in main. It failed. Move source slash. Alright, so how do I use this? Now, as stupid as this sounds, can I run the benchmark in debug mode? What icon is that? Yay! Cargo bench debug mode. Searching doesn't help very much for cargo. Is there like a debug? Cargo bench help. How do I benchmark in debug mode? I know it sounds stupid, but it's what what's coding game runs as. Yeah, that's what I'm guessing, and that's because I mean, if we were getting that time that it gave, we'd be fine, but we're not getting anywhere close that time. Aha! Thank you. Where? Right here? Like this? Profile.bench then. This is what you mean then. Profile.bench. Let's see what we can get. No, it didn't copy. I don't know why. This shouldn't affect the speed, but sometimes it does. I'm just trying to get their horrible thing on. Let's see if that makes a difference. Well, it still says optimized. Okay, but it's shitty slow now. It's only about 6 times as slow though, so I think we're still not quite in debug mode. Is there any way I can reduce it even more? Maybe it's good enough. Alright, bench RS. Well, let's turn it up to 4, because this actually caused it to fail on their system. It's still going too fast. So their system's still a lot slower than this, because I couldn't put 4 there. Alright, in any case, now I have to figure out how to use benchmark. How do I figure out from this? Does this actually put out profiling output, or no? Is that, do I have to call this bencher on every single one of them, or is there some way I can just do the profile function outputs? What I want to see is the function breakdown, where the time's coming from, without passing a bencher around everywhere. I guess I could investigate certain things though. Well, let's just investigate certain things then if we can't do it. Bencher. Rust bencher. Well, I want a profile. I don't want a bench. I actually want a profile. I could just do it, but I can do a few things. I can confirm some theories this way. I don't know. Okay, we learned a bit more, but I don't know if we're going to be able to do that. The problem I fear here is that the state, if I start benchmarking the cloning of it, we don't actually need to do that. Is that we're missing details. We're missing a current player state and stuff. Like, this is going way too fast. It can't just be my system. We're still compiling in some sort of optimized mode because coding game is getting just... It gives you like 50 milliseconds, I think. 50 milliseconds. And 4 timed out. And 4 has only 1 millisecond. So we're like way too fast compared to coding game, but we can probably deal with that. We can still find out the slow bits. Is there something I can do like in a loop, benchmark in a loop? What I want is I want to call something like 1,000 times or something, bench n. What does bench n do? Let's do bench n. There's no bench n. Well, so much for that. Must be a different version thing. Which version of this do I have? I don't know. Can I just like jump to a different version here? Oh, come on. 2.0. So I don't have these functions, which is kind of what I want. Because iter's no fun. Iter's just going to give me one iteration, which isn't going to be enough. Wait, it only reports one. Let's just go away here then. Ouch! That can't be taking that long. Oh my goodness. That confirms two microseconds to clone state. That's awful. Awful, 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 awful. How fast can this actually go? Yeah, see, that's that's more like it. Wow, this is... Yeah, it's a deep copy, but there's not much in there. This 115, I bet, is dominated by a actual memory overhead. Actually allocating the... So, yes, story computers... 2 microseconds is absolutely awful. Like, look at this time here. This is 115 nanoseconds, and even this number I think is too high. But it's kind of acceptable. It's somewhat acceptable. But I'm only running one iteration, and let me run a few of them first. Oh, profiling. Oh, let's just stick with this for now. Our profiler. No, stick with this. For now. And 0 to 100. We'll just do it this way for now for bench n. What's it doing? Hello? Hello? It's doing something? It's doing something. It's stuck. It's thinking, yeah, it's thinking a long time. It shouldn't be thinking so long. Hello, thinking. Can you think less? Plus or minus 40. What did it actually run plus or minus 40? How many times does it run it? I'm guessing not. Why not, though? Well, no, I want variance. I want this. I want it to report average value with variance. That's what benchmarking is supposed to do. So whatever this is here, they've considered this, but I just don't know what it does. They're undocumented. It's just unclear what bench does. I wanted to run it multiple times. But it says 1 measured. How can I get it to go multiple times? Rust, bencher, iter. I don't know how to use it. And I'm afraid of being optimized out as well, which is a problem. I don't know how to use it. I don't know how to use the benchmarking tool. 1 iteration's not enough. And I don't even know if it's using this result. It could just be optimizing it away. Okay. I don't understand this, but the several... Okay, so it does do more, which is good. Now, this nanoseconds here might be an issue because this is probably just being optimized away. This is probably 100% iter overhead. Because the clock in my machine probably, when I last measured this on Intel and AMDs, they take up to, that function to get the clock time takes up to 60 nanoseconds, from 30 to 60 nanoseconds depending. So this could be 100% clock time. And this has just been totally optimized away. And so what you need to do is get rid of the optimization, let mut q equals 0. Q plus equals, so let dup equal dup dot player 0 dot samples dot length. So we read something from it to prevent it from optimizing it out entirely. And this should increase the time. It went down. Oh, wait, we still not by using this ePrint line. It still could be optimized out. Profiling to benchmarking is very hard. You have to make sure all the values are used, otherwise it just optimizes them away. Where did it print my result? That's a debug, so it might not print it in this mode, in optimize mode. Wilkins, I need to get the averaging count. I want to see. Well, I'm not doing the looping now. I'm really trying to see. I'm trying to make sure if it's not just optimizing this out. I don't know where it puts its output though. Hi. It's not showing any output here in the bench output. Hello, Barney Rebel. Nice to have you on the show. So this takes longer when I do this, but it may be the printing. How can I get the output of... Well, that's enough to confirm it's not optimizing it out, I think. So this Q here, the reason I do this, and this is something very important for benchmarking, is that this state clone, if you don't assign it to anything, the optimizer can rightfully look at it and go, you don't use it, let's get rid of it. Yeah, Barney Rubble, I thought about it a few times. That's something I've really thought about at times, but we're going to stick with it. So what I do is I take Q, and this looks inside the state that's result, player 0, samples 1, and the optimizer probably can't figure out how to get rid of that. Therefore, this probably isn't optimized away. Now the timing, I didn't write this benchmarking. Well, destroy computers, it doesn't have much of a choice. If you compile, because when you compile an optimized code, you want to compile optimized code, and if it sees that the value's not used, it'll get rid of it. I don't know how much you do in here, because in C++, we had to go out of our way to get this stuff not working. C and C++ have the volatile tag, and volatile does exactly that. Volatile will let you say something like, let volatile, and that would tell the C++ compiler that whatever it's not allowed to get rid of this. It has to use this it has to use this value. And so we had function that did it here. And this 115 here time, the time it actually gets, this is possible. This time is definitely possible for state. I don't know the inner workings of bench, and I don't know if it's accounting for clock time overhead. If it is, then this is a totally reasonable time. Well, actually, if it is, this is slow, but maybe it's okay. But let's go back to what we had. We had craptacular things here of, this is the thing we actually do. Yeah, it's hard to say. You can use volatile and rest? Okay, well then I could also use volatile there. I'd have to learn it. But we're dealing with this in any case. This monstrosity here of 25 times as slow. And this 2.5 milliseconds, to get back to what somebody said, 2.5 microseconds is awful. This really screws up our code. Because this is the call one clone function, 2.5 microseconds. That's what I was looking for, no capture. Where do I have to put it? Yes, that's what I was looking for. Black box, yeah. That's good enough. Can I just do this? Black box. This should prevent getting rid of it. That's that function we're looking for. I'm just going to assume that's written correctly. So we don't need the no capture then. Undeclared use of module test. That's that, but use test. See, but destroy computers, that's slightly different. That's taking the result of inner. That's saying whatever inner returns to get rid of that. So this is the same as state.clone, and you have to be very careful here not to put the semicolon. And this will then, if you're looking at that code, that should prevent the optimization. Alright, so we have it slow. Okay, it's slow because so clone is slow, and the reason why 2.5 microseconds is a problem is because if you think of the number of turns we have, and we do this iteration, each time we can have 6 or 8 turns, and that becomes like 6 to the 4th, right? So 6 to the, if you want to go down 5 levels, which we want to go down, where's my stupid thing? So 6 to the 3 is what we're going down. That's 216 clones already. Now to go down to 5 levels requires 7,000 clones. And 7,000 times 2 microseconds eats up our 50 millisecond time limit. It goes away really fast. So obviously we have something else going slow here, but this is a huge overhead. And I imagine it's worse than this in practice because we might be fragmenting the memory. And how can we benchmark just one thing? Let's benchmark another thing. Where's another benchmark? We can do function read state. Let's just do this. Read state is a state. And I'm going to do another function. So this will be the clone function, and this will be enum turns and mut bencher. What is zeal? Barney Rebel. New, and we're going to do state dot enumerate turns and turns. See how long this one takes. Need a mut. Okay, so enum turns is also not very nice. Yeah, I mean, I know what a zeal is, but I have no idea in reference to programming what that means. You mean like reference to Rust, which is going to be hard trying to find anything. Oh, it's another programming language. Or what? Seal ducks. Hey, thanks. Yeah, that would. Now you got it at the same time, but yeah, okay. You know, I've been looking for this for a while. I actually started programming without having online. And so offline docs I used to really like, but what happened at some point is the offline docs got so bad, but this is actually probably going to be really nice because I definitely looked for this for all programming languages because I hate going online for docs. I'll get this later though. I bookmarked it and I'll grab it later. Okay. So now looking at this, enum turns is really slow as well. Yuck. Yuck, 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 yuck. That's a really... It's faster than clone though. But wow. Debug mode's killing us. Now let's do one more. Let's do apply turns. This is going to be a bit harder. We'll just apply all of them. There's only 5 in here because from the base state, all we can do is... all we're going to do is walk, but at least gives us some idea of the overhead of this state.apply turn. Apply turns 0. Let me get the state back. I'll pay you in bits, Barney Rebel, okay? I'll pay you all my accumulated bits so far. enum take turns. And this probably takes 5 turns, so we'll see what it does. Yeah, it's been an issue to use release mode. I don't know why they're trying to dragging their feet on it for some reason. And cannot move out of captured outer variable in fn mut closure. All right, so this is the case where we have to use test black box because I have nothing to return here. Well, I can just do turns.len here. Self.player0. What do I want to give out here? Let's give it a... I don't know what it applies. That should be enough to make sure it's not optimized out. Oops, yeah. Clone, slow. enum take turns, okay, that's also slow. Turns, a bit slower. So this is roughly our iteration cost of 1. 6 microseconds to iterate 1 future turn. And we already know we're going faster than coding game because the clone is... we're maxing out at 4 turns. We could easily do 4 turns here. But just so you guys have a reference here, if we put this back to op level 3... the values are much, much nicer. 20 times. 20 times the cost, at least 20, 25 times the cost. So that cuts us down by 25. That should only cut out 1 level, but we know coding game is going a lot slower. And so we're going to have to improve this speed if we want to do it. And that's for all of it. And this is mainly all memory allocation, I think, because enum turns bugs me the most. Well, let's do one thing first. Is there a quick way to emit things from the tests? So what we can do in take turns here is iterate it the exact same we did in the program. So what we have is we have 2,6 microseconds. And let's move this out to here and do turns.clear. In theory, this should be a lot faster. If it's not, we're in trouble. Because the initial allocation has overhead, but we're reusing the same, and it did absolutely nothing, which is really depressing. What about in release mode? There we go. So in release mode, it makes a huge difference. And this is what you'd expect to see. enum turns takes 14 nanoseconds. This is good. This is what we want. And because if you look at enumerate turns, it does one if. It enumerates goto, which is a simple loop. And it's going to inline this because it sees a simple loop. It's going to inline this. It calls push a few times, and that's all going to be inline. And 14 nanoseconds is a good valid amount for this. It's a good amount. And this lets you take lots and lots of stuff. So the approach is fine. Enumerate turns. There might be a few other things we have to do too as well. And we're not enumerating all of them, but that gives us a good idea that at least it makes a big difference. In non-debug mode, the fact it didn't make a difference is really bothersome. Why on earth would it not make a difference in debug mode? So let's do it in takes turns as well. Turns.clear. And this keeps applying the state too. So all these states, it keeps adding up. So that's actually good. Yeah, and this is, wow. So our code is actually super fast. This leaves us royally screwed on coding game. The reason it leaves us royally screwed is because I know how to make the clone go away. I don't know how to make those other two go away. So I can cut out half the time, but what does that buy us? That gets us down to like maybe one more look ahead. And one more look ahead isn't going to buy us much. I need to get at least two more. And this enum turns, this is a real problem then. These are taking too long. And the optimized mode, and I don't even want to optimize clone because if you look at its release mode, it's so fast in release mode that everything I do to optimize it is actually going to slow it down in release mode because it's going to be less, attempting to be clever, it's going to be hard to outwit 160 nanoseconds for clone. And we could do it, but it might add overhead, it might add tracking cost, and this is the same problem we hit in Tron, and this is kind of, yeah. We're really going to have to talk to the coding game guys. There's just nothing we can do about this. Because my next best attempt here is that the loop we have right now, the reason why, and if we look at the code, well, it looks like this now. It's just slow. It's just too slow. And the biggest problem we have is what the robot's doing right now, and unfortunately I submitted the code that's going to break, is he goes here, and watch, he picks up one sample and goes there. And that's because he doesn't look far enough ahead to realize picking up two here is going to give him more value here. And I'm guessing I need to go at least 5 steps in the future for him to pick that up. And there's no way we're going to get anywhere close to 5 because 4 is already timing out. And I have no way to optimize it. I could optimize it a little bit. To get down to 5 is going to be hard, even if I start doing pruning. But I don't think we can go far enough with this approach. We'd have to take a different approach. And it was the same problem we had in Tron. Like, Tron was the same thing. Tron, my bot just got dead in the ranks. He didn't get any further because I was making a prediction failure. But when I ran it locally, if I just increased the step count, or if I changed the algorithm slightly, I had no problem predicting it correctly. But there's just no way to do that in coding game because the cost was too high, and without optimized code, it just takes too much time. And the reason you don't optimize against the that's why I was doing this is why I changed the benchmark destroy computers, as I wanted to prove something, is that on the enum turns I moved vec turn in and out of here. And what I did is that removes the allocations, because now this enumerate turns takes no allocations. But In debug mode, that made virtually no difference in the cost. Whereas in release mode, it made a huge difference. So the reason why it won't make any difference to optimize state is because if this simple thing here, if this simple turns enumeration does not speed up from avoiding the allocation, there's no way the start clone is going to speed up, because we're not even cloning here. Basically, whatever it's happening here is I can just avoid it, and I can probably avoid the clone, but I'm just going to replace it with another cost. But the issue here is still this stuff here. Even if I can completely remove the clone cost, even if I completely remove this cost, I still have this cost. And I can't get rid of this cost. So I'm really stuck, as I may be able to, if I work really hard, I can squeeze out one more look ahead. But I'm guessing I need to go to at least 5 or do pruning and stuff, and this is a real problem. And it kind of kills my motivation for it right now, because I know I have scoring errors, and yeah, I don't know what to do with it. I think I'm just going to leave it for now. We're going to come back to it. I think competition-wise, we're going to have to be aware of the debug stuff. We're going to have to be aware of an algorithm that we can't do too much scoring in advance. So it's going to limit what we can do there. So the competition, we might have to go expert system approach. That's what we did in one of the previous ones. So scoring, because of the debug mode, we might not be able to actually do proper mini-maxing, because we can't look into the future far enough. And I mean, 20 times speed difference is that this is also, I also know because of what we just did online, is that we're actually not even getting this, we're getting even far worse than this on coding game. So I don't know what we're going to do with the competition, but I'm going to just leave this for now. I think we pushed this. I mean, our scoring isn't that great. We have scoring issues, but I think fundamentally, looking in the future, we'll solve them, because my biggest one now is when he does exactly what he did right there. He picks up one sample. This would just be fixed by looking more turns into the future. If we simply looked 3 more turns in the future, we would actually find that getting more samples here is more valuable. Or we can start hard coding more rules, but that means rewriting everything around it. So I think I'm just going to leave it for now. I'm going to come back, if not tomorrow night, then Saturday morning. If I don't start tomorrow night in the competition, I'll start early Saturday morning and see where we can go with that. And I think I'm just going to leave this one for now, and it's unfortunate we can't go further, but we're fighting with the lack of optimization, and we have to do something. We have to convince coding game to enable optimization, because it's just going to kill us otherwise. And some of the other languages are optimized, which is interesting, which makes it really not fair. And so we'll have to see. I was hoping to get further, but thanks for watching me. Thanks for all the help you guys gave. I'm going to go try out Zeal, see if it's nice in the system. I'll try Zeal for local duck, so I don't have to go online so often. And thanks for all the benchmarking tips. We did learn a lot of we learned all this benchmarking stuff in Rust, which is great. So now I can do the benchmarkings. And having this basic benchmark function is really helpful. I've written this like in every other language I've used. So I could save myself writing it in Rust, but if I had to do low-level stuff, I'd still investigate the code, because you really have to trust the code. And so hopefully I'll see you tomorrow night or Saturday morning, or that might be the same for some of you, but I will be doing the competition this weekend. We will be doing, for example, we're going to leave that. We will definitely be doing, when it loads, definitely be doing the Borders of the Galaxy, which starts in 18 hours, but again, I won't start at that time. I'll start a bit later. We should be fine with that. And I thank you very much for watching. Thank you for the follows. Thank you for the subscriptions for those who subscribed. And thank you for the tweets and stuff. And I look forward to starting this competition as soon as possible. And I might do a stream tomorrow showing the progress of Leaf with creating an SDL window. I got an open green window. I'm going to try and load a graphic. If I can load a graphic, I'll show it. Otherwise, I don't want to show you the boring debugging. But we'll see that tomorrow. Thank you very much. And enjoy the rest of the evening or night. Bye.